Right, look at section 3 of chapter 9, which is how lines intersect, in particular in 3 dimensions. Just before we start, remember we've now got vector equation of a line, point on a line, and a multiple of the direction, and we've got the Cartesian form of the same line. The 3 components that make up A would appear there, there, and there. The 3 components that make up B would appear there, there, and there. In fact, and at some point we can look at the special cases when these components are 0 and whether it matters if there's zeros in A or zeros in B. Anyway, if you've got the book, the first example wants to know, can we find where these 2 lines intersect? And they've used 0, minus 4, 1, so that's a point on the first line, and a scalar multiple of this, so 1, 2, 1 is the direction, and the equation of the second line is 1, 3, 5, so that's the direction, that's a point on the line, and a scalar multiple of 4 minus 2 minus 2. Notice it's good for me if you've got 2 lines to use 2 different letters for the, or symbols for the scalar multiple. They intersect when these 2 things are equal, or they intersect if we can find values of lambda and mu which make those equal. So if they intersect, then we get 0 minus 4, 1 plus lambda 1, 2, 1 equals 1, 3, 5 plus mu 4 minus 2, 2. And more particularly, we can put all the I bits together, all the j bits together, and all the k bits together. That would imply that naught and lambda, so the i's give naught and lambda equals 1 and 4 mu, minus for the j's give minus 4 and 2 lambda, minus 4 and 2 lambda equals 3 plus minus 2 mu. See, I got away with getting the wrong symbol there, didn't I? And the k's, because we're working in 3 dimensions, we get 1 plus lambda equals 5 plus 2 mu. Now notice what we've got is we've got 1, 2, 3 equations in 1, 2 unknowns. So simultaneous equations in 2 unknowns. What we do is we pair any pair of them, because we only need 2 equations to find values of lambda and mu, and we take the values of lambda and mu we've got and substitute them into the third equation to see if there's consistency. What do I mean by that? Let's say we take, let's call them 1, 2, and 3. Easiest way to solve for lambda and mu might be lambda's the subject. I'm going to substitute equation 1 into equation 2. So sub 1 into 2 minus 4 plus 2 lots of 1 plus 4 mu equals 3 take 2 mu. So what we've got, minus 4 plus 2, take 8 mu, the minus 4 plus 2 is minus 2, 2 times 4 mu is plus that, is 3 take 2 mu, so I'm going to add 2 mu, 10 mu equals, add 2 is 5, mu is a half. Right, lambda is 1 plus 4 mu, therefore lambda is 1 plus 4 times a half is 2, 3. Remember, that's what we've got from combining these 2 equations. So we were going to find a value, well, we have found a pair of values which you can from solving a pair. Now, the final thing is to check for some sort of consistency or not, check in 3, 1 plus, what was lambda? 1 plus 3 is 4. 5 plus 2 times a half. Well, that's a shame, isn't it? So let's do that again, shall we? 10 mu. Right. And if we find out why that's not quite working, we could go all the way back to, I'm sure, what you were screaming at the page. That first one should have had a negative there, shouldn't it? Which changes that to that, which makes that 4, which means it works. Right. Always worth. There, I did that deliberately to show you why it's important to check things. So, if you're asked to find where they intersect, there shouldn't be any trick questions. Solve 2 of the simultaneous equations and check for consistency in the third. If you're asked to show they don't intersect, solve a pair of them and show that it doesn't work in the third equation. Okay. In the next example, they're looking for us to show that a pair of lines don't intersect. Now, an important thing to note is, in 2 dimensions, if 2 lines aren't parallel, in 2 dimensions, if you've got 2 lines which aren't parallel, they will intersect, okay? 2 non-parallel lines always intersect in 2 dimensions. That's not true in 3 dimensions. In 3 dimensions, you can have lines in parallel planes which aren't the lines themselves not parallel, but they don't intersect. Those lines are called skew. How do we know that these 2 lines aren't parallel? They are not parallel because the direction vectors are not multiples of each other. So because the direction vectors aren't multiples of each other, either they intersect or they are skew. So how do we go about showing that they don't intersect? Because that's what the question says. We form the 3 equations. We take the I, so if they intersect, the i's would give minus 4 plus t equals 2 and 2 lambda. Now I better check I've actually written the right question down this time, shouldn't I? Minus 4, 1, 3, 1, 1, 4, 2, 1, 1, 2 minus 3, 2. Right. J's 1 and t is 1 take 3 lambda. K's 3 and 4t equals 1 plus 2 lambda. Should we just remind you there is a different way of solving these at A level from a GCSE. I could write this one as t take 2 lambda is 6. This one becomes t plus 3 lambda is 0. And this one becomes 4t take 2 lambda is minus 2. 4t take 2 lambda is minus 2. So I'm going to divide that by 2 and get 2t take lambda is minus 1. If you number them, remember at A level, we can simply use the calculator to solve simultaneous equations. So let's put it into the solve equations mode. Let's pick simultaneous equations in 2 unknowns, and let's pick solve 1 and 2. So I've got 1 minus 2 6, the 1, minus 2 and the 6, then I'm going to have 1, 3 and 0. So that would be t is 3.6. That was lazy, wasn't it? 3.6. And the lambda is minus 1.2. I've got a choice. I could now either solve 2 and 3 or 1 and 3, and because we're told they don't intersect, find a different pair of values. Oh, let's zoom out. Or simply show that sub in 3, show that these two values are inconsistent in the third equation. 2 times 3.6, take minus 1.2 equals, so that's 7.2 plus 1.2 equals 8.4, which is not equal to minus 1. Therefore, they do not intersect. Okay? They are skew. They don't have to be parallel to not intersect. While we're going on, before we go on to the next one, just want to remind you that from the previous question, one of the lines was minus 4, 1, 3 plus t times 1, 1, 4. A point on the line, the direction of the line. The Cartesian form of that equation would be x, take that value, divided by that value, is equal to y, take that value, divided by that value, z, take that value, divided by that value. Or, we don't have to divide, the right is divide by 1. The Cartesian form of that line would be this. Okay? Worked example 9.14 is a good one. It wants us to find where does x minus 6, 2 equals y plus 1 over 7 equals z plus 9 over minus 3. Where does that intersect the y-axis? Now it is good this. Do you remember in 2 dimensions the x-axis was y equals 0 and the y-axis was x equals 0? In 3 dimensions the y-axis is where x and z equal 0. So if we want to find where this Cartesian form of it intersects the y-axis, we can substitute these values into this. So we get 0 take 6 over 2 equals y plus 1 over 7 equals 0 plus 9 over minus 3. Minus 3 equals y plus 1 over 7 equals minus 3. Consistency. Therefore, multiply by 7 and take the 1. Y equals minus 22. Intersects y-axis at 0, minus 22, 0. And the next part of the question is a good one. It says, show the line does not intersect the z-axis. Do the same thing, but there will not be consistency here. While we're at that one, this line here, that line there, is the line that goes through, change the sign of those three, 6, minus 1, minus 9. that is a point on the line and a multiple of 2, 7, minus 3. And we could just as easily have done solve 6 and 2 lambda is 0, minus 9 take 3 lambda is 0. And I think they both give us lambda is minus 3, then minus 1 plus 7 times lambda equals 7 lots of minus 3 is minus 21, minus 22. Position vector of intersection is 0, minus 22, 0. Right, have a crack at 9c. Just looking at it now. So 9c starts off with, do these intersect? If they do, find the coordinates of intersection. It's a nice straightforward one. 2 almost the same. And then we've got 2 more in vector form, 2 in Cartesian form, and then 2 to 6 show that they're skew. Okay then, what does the word skew mean? Show that these lines intersect and find where they intersect. Determine whether that line crosses the x-axis. So that's going to be similar to that example we were just looking at, that one there, isn't it? And then this line does cross the y-axis, find where it does. Show that these 1, 2, 3 lines form a triangle and find its area. Actually, I'll leave you with that because I'm not sure. How would we find the area of that triangle? First of all, to decide whether they form the triangle, think about those. And then maybe, if you're not sure about that one, you could email me, and before Thursday's lesson I could go through that one. Right, good luck with those.